Good morning, everyone behind the screen from around Europe, even Asia, the Americas. A really warm welcome to this final event of the FABULOS project. And you're actually lucky you're behind your screens at home because it's -20 here in Helsinki in Finland. So think of how that would have been otherwise. But anyway, my name is Renske Martijnse-Hartika. I work for Forum Virium Helsinki. That's the innovation company of the city of Helsinki. And I'm the coordinator of this FABULOS project, an EU-funded 3-year project. So for the past years, we worked on automated shared mobility with a fantastic group of partners and companies. And today we are finally ready to share some of our lessons. So I'm really proud to say that we have over, I think, almost close to 400 registered participants today. So what a turnout. Thanks very much to all of you. I hope we can provide you with an interesting program. We have various nice videos, a lot of different panelists, and we'll take the perspective of both cities as well as companies in our discussions today. We will start with an introductory video of FABULOS, and after that I will introduce you to the keynote speakers and the rest of the program. Remember that throughout the day you can ask questions via the chat. For those of you who cannot maybe stay the entire day, it will be recorded, the conference, and it will be sent to you afterwards. But now, to give you a very first impression of FABULOS, we'll start with a 2-minute video. Enjoy.
The FABULOS project focused on how cities can use automated buses in a systematic way. Smarter transportation systems are playing a crucial role when facilitating sustainable development of public transport and designing future cities.
FABULOS stands out from other robot bus projects because it's really based on the needs of cities. There's a group of 6 cities and public transport operators who work together to really push the market to come up with innovative solutions for robot buses. We work together and fund companies in order to progress the state of the art.
Selected robot bus prototypes were tested as small fleets of shuttles in Estonia, Finland, Greece, the Netherlands and Norway. With these real-life demonstrations, FABULOS focused on finding a turnkey solution that is scalable and enables agile integration of robot buses into cities' existing public transportation systems. How could automated buses transform urban mobility? For cities, robot buses mean more attractive, flexible, cost-efficient and sustainable transport solutions. Citizens, in turn, get more tailored urban mobility alternatives, enabling seamless transfer across the public transportation network. FABULOS has resulted in major technological developments and has strengthened European cities and companies as frontrunners in the field of autonomous transportation. We are on the verge of a breakthrough in public transportation, and we are proud that FABULOS has greatly contributed to this.
I hope you liked that. This was FABULOS in a nutshell. I hope it piqued your interest. You saw already many of the different vehicles that have been used in the project. More details, more videos, of course, throughout the day. In this morning session, we will first hear from 2 keynote speakers. I'm really pleased that the Minister for Transport of Finland here, Mr. Harakka, has taken the time to send us a video message where he talks, among others, on about legislation, data, safety, much more. And after him, we will hear from Mr. Mashgani, who's the Secretary General of the International Association for Public Transport. He will talk, for example, about user acceptance, integration in public transport, some of the European sister projects of FABULOS as well. And after that, I'll come back to you, and we continue with presentations from the companies the ones who have developed these autonomous shuttle bus solutions. After we have heard from them, we get the viewpoint and the experiences from the procuring partners. So that's 4 cities and a public transport operator and a ministry in our case. Then after lunch, 3 panel sessions on regulatory aspects to start with, 1 on technical progress and 1 on innovation procurement and next steps. So really full program, but I'm looking forward to it. At least I hope you too. You can access all these sessions with the same link that you are watching this. I think that's it. I think we go to the videos. First, Timo Haraka, Transport Minister of Finland, and then Mohamed Meshkani, Secretary General of the UITP. Enjoy.
Dear participants, I'm delighted to give a speech at this conference today, and on my behalf, a warm welcome to you all. In Finland, we are preparing a strategic plan for transport automation. It is a huge entity that covers all modes of transport. The plan broadly addresses regulation, technical development of autonomous vehicles, the digital and physical infrastructure required for transport automation, and the exchange of transport data. We are currently finalizing the plan according to the feedback we've received. We are seeking to launch some of the legislation projects that aim to advance automation already during this year. Worldwide transport automation has not progressed as rapidly as we hoped a few years back. The fact is, however, that progress is inevitable. Automated functions that support human activity are increasing on all modes of transport, although fully autonomous means of transport entirely without human power still seem to be in the fairly distant future. We've decided to set our goals realistically in order to be able to utilize the benefits of the progress of automation at every development stage, rather than waiting around for the still distant full automation. According to our vision, automated transport is safer, more efficient, and more sustainable compared with the current state of transport. However, the development we hope to see will not become a reality without a clear common goal and joint effort. An example of efficiency and sustainability could be using autonomous vehicles to provide mobility as a service solutions in feeder transport for urban public transport trunk lines and in sparsely populated areas. This operating model would help achieving efficiency and sustainability goals way better than a growing self-driving car fleet. At the same time, the need to purchase a car or at least multiple cars for every household would be reduced, and people would be able to use their money for other purposes. Steering development in desired direction requires effective cooperation between all parties, public and private sector, as well as research institutes. Dear friends, road transport automation is advancing in spearheads, with remote-controlled minibuses having progressed the furthest. Supporting such spearheads is also one of the goals of the Finnish automation policy. In the first phase, the goal is to proceed from the pilot and testing phase to the production use of services in urban feeder transport. The long-term goal is for mobility services provided by automated minibuses and robot taxis operating on certain routes or in certain areas to be in production use throughout the country. Trip chains formed by such services would be competitive in urban feeder transport as well as in sparsely populated areas, together with owning a car. I'm very happy and proud that one of the FABULOS project pilots has taken place in Helsinki, and that Finland has a pioneering approach to the development of these services. We want to specifically to be recognized as a promoter of human-centered automation, and these pilots support this goal. At the same time, these pilots have strengthened our profile as a country seeking to enable automation and more generally digitalization. In a report recently published by KPMG, which ranked the autonomous vehicle readiness of 30 countries, Finland placed 5th. For the time being, Singapore, the Netherlands, Norway and the United States were ahead of us. Our pilots with autonomous minibuses was specifically mentioned as one of our strengths. In addition, Finland's strength has long been a progressive and enabling regulatory environment, which we are strongly committed to develop further. In principle, the regulation of road transport automation is and must be international. When it comes to regulation development, we want to see a new holistic view of what goals we set for automation development and how, for instance, individual regulatory projects implement these major goals. And these major goals are sustainability, safety, efficiency, and being human-centered. Over the decades, transport regulation has evolved into the regulation of technical details, but owing to the rapid pace of development and the increasing use of artificial intelligence systems, the old regulatory model has reached the end of its path. There is a need for a target-based, performance-based, and risk-based regulation that sets objectives which can be reached using measures that can be implemented in many ways. Ladies and gentlemen, developing a regulatory framework for the automation of road transport will be a very challenging, albeit extremely interesting, common task in the coming years. Along with the development of the automation, the human role is also becoming more diverse. In addition to the role of a driver, a person can act, for example, as the end user of an artificial intelligence system or as a controller or supervisor controlling several vehicles remotely. One key task is to identify and define these different roles and the responsibilities and rights connected with them. International road transport agreements require that the vehicle always has a driver. One of the advantages of automated minibuses is that they usually operate under remote control, thus they meet the key requirement of having a driver. Preparatory work for the necessary amendments to the international treaty system is underway, but it will take some time to make the revisions. The Finnish legal system already allows the driver to operate outside the vehicle. This is an example of how we have sought to ensure that legislation paves the way for automation to move forward. As well as artificial intelligence systems, transport automation is also based on the use of data. Sharing digital data between autonomous vehicles, for example, is the data economy of the future at its best. Transport automation requires static digital data on the transport infrastructure as well as dynamic data on, among other things, the traffic situation and conditions. With regard to data on transport infrastructure, our goal is to produce an utmost up-to-date digital model covering the state-owned road network and the municipal street networks. The basic data is already available in machine-readable form over open programming interfaces from the DigiRoad service, but there's still work to be done in order to create the actual comprehensive digital model that can be utilized in automation. A greater challenge is to make dynamic data better available for automated vehicles. Dynamic data is collected mainly by vehicles and is considered personal data. Utilizing this data while ensuring data protection and cybersecurity is a shared European challenge. For some types of data, the implementation of the Intelligent Transport Directive has meant progress, and further progress may be made in their reform. It's, however, understandable that industry players are calling for clarity on the potential utilization of data. One way to promote this is to advance measures of the so-called My Data model. These measures would help people to manage the use of their personal data, thus improving our possibilities to access more data. Ensuring safety is a key issue in the development and utilization of transport automation. Automated minibuses operate in urban environment where there are many so-called vulnerable road users, that is, pedestrians and cyclists. It's important that people can trust in the safety of automated vehicles. The transparency of the human-machine interaction is key to building trust. It's important people to know when they are dealing with a machine as well as to understand what is expected of them then. In addition, building trust also requires so-called algorithmic. It is important that independent third parties, such as public authorities or inspection bodies, can verify the safety and cybersecurity of automated systems and the rationale underlying decision-making systems. Ensuring safety also means that companies should commit to culture of responsibility, that is, the objective to develop and utilize automation ethically and in a safety-based manner. There are still many uncertainties associated with the development of transport automation. For this reason, testing and piloting will continue to be very important. As with digitalization more generally, we can only see a few steps of the path ahead. The rest is covered in fog. The lessons we learn from experimental testing will help dispel the veil of fog. It's important that we have closed testing environments that make it possible to test systems in the early stages of development. It's also equally important that systems in the advanced stages of development can be tested in real transport environments. 3 tests of this nature have been the object of the FABULOS project. Testing also requires a public sector that enables activities in terms of both legislation and permit practices. Finnish legislation enables testing on the entire road network, and in order to obtain permits, we've developed a one-stop shop authority service for the Finnish Transport and Communications Agency that aims for flexible practices. Of course, with regard to pilots, there's still work to be done at the European level to establish a system for mutual recognition of pilots and disseminating information on the completed tests and their results. One of the challenges associated with the use of automated transport systems is the impact that severe weather and road conditions have on the systems. Vehicle sensors are still quite sensitive, for example, to fog, dust and heavy rain, not to mention snow or ice. In Finland, we have our share of these challenging weather and road conditions, so it's safe to say that if the system works here, it will also work in similar conditions elsewhere. I'm therefore pleased that the pilots conducted in the Helsinki FABULOS project have paid special attention to the endurance of vehicles in challenging conditions. Ladies and gentlemen, a lot of work has already been done, but there is also a lot of work ahead for all of us. Today, it's a time to examine the results of the 3-year-old project and review the lessons we've learned from it. May this be a springboard for the next steps that will take us towards large-scale mobility services provided by automated vehicles. I wish you all a very interesting conference day.
Hello everyone. A very warm welcome to all of you to today's FABULOS conference. I hope you are doing well and are safe. First and foremost, let me congratulate everyone who has been involved in this ambitious project. It's been about 3 years since the project commenced. I'm excited to hear more about the results and lessons learned from the various consortia. I have no doubt that the research and learning shared today will play a part in the expedited evolution of automated shared mobility in Europe. So, to all the participating cities, the sector greatly appreciates the unmatched knowledge you will be sharing. It has always been important for us as a sector to share on ways to improve our services and offerings, keeping the customer needs at the center of our decision-making. Especially during these times, it's even more evident that we must do our best to ensure each journey is convenient, seamless, and safe experience for our rider. This will help us ensure that our sector has the competitive edge in providing mass mobility solutions. The landscape and context have rapidly changed in the last year, obviously because of the crisis. But an important outcome of this has been that our sector's mindset has also progressed. So we find ourselves with the unique opportunity to look at the situation with a fresh perspective and renewed determination, while taking the new developments into consideration. The EU Commission has rightfully stated that autonomous vehicles have the potential to bring down road fatalities to near zero, increase accessibility of mobility services, and help to reduce harmful emissions from transport by making traffic more efficient. Safer and widely usable services are surely the needs of the moment. But as this is certainly being considered as a long-term solution and not a quick fix to certain mobility issues, it is certain that before we get to the point of benefiting from these desirable outcomes, vital work needs to be put in to ensure its success. Massive conscious efforts are needed towards the development of technologies and infrastructure of cities to support the strong deployment of autonomous vehicles. Another essential point to reflect on is if our riders are ready for this type of technology yet. What is their comfort level on riding a driverless vehicle? User acceptance will also need to be thoroughly investigated. Finally, the AV needs to be given the best chance to find its place in the mass transit ecosystem. So we need to agree on a vision for autonomous vehicle deployment to reach maximum benefits for our society and thus achieve maximum success. So how does UITP envision this? Where do AVs fit in the mass urban mobility universe? And what part will it play? Surely a crucial one. AVs can have significant positive impacts on the capacity for people to access social life, such as their places of employment, schools, healthcare, etc. It also impacts health and resources with its multiple effects on the environment and noise levels. It will help return essential urban space regained from traffic and parking to the public to enjoy, but only if it is used the right way. So, what is the right way? Well, there are many schools of thoughts on this, and I will share UITP's vision. But first, let me explain how we reach this conclusion. Swapping privately owned vehicles for privately owned autonomous vehicles isn't providing a real solution. The public still cannot use its space because it's still taken up by vehicles, only different ones. Those that cannot afford this or don't want to own a vehicle will still have limited or less comfortable access to their day-to-day activities. This is not providing a solution for the masses and is unsustainable. What about shared fleet of vehicles then? Well, this will surely help with reclaiming our streets from private vehicle traffic. It would also improve access to public transport as well as provide a mobility option for those without cars. On the flip side, this option would increase the vehicle miles traveled, resulting in even more traffic. With small vehicles replacing larger buses and metros, this would cause inefficiency in mass travel. In terms of health, this would discourage many from walking and cycling. And of course, this would directly compete with traditional public transport. So, while this solution offers better mobility for many, it also comes with the undesirable complication of being far less efficient. But if shared fleet of vehicles are integrated with traditional public transport services, would we achieve a more widely favorable scenario? Let's think about it. In this case, we would be able to reclaim our streets on a larger scale because traffic would have reduced. Access to public transport would be highly improved with the AVs helping riders cover the first, last miles and short distances. Those without cars would be able to travel much more conveniently. Vehicle miles traveled would drastically cut down, and cost per kilometer would be low. Large and small vehicles would perfectly harmonize on our streets, giving our riders multiple efficient choices to cover ground, including walking and cycling. Knowing these points, The optimal use of autonomous vehicles is in its shared usage, where fleet of cars are integrated with traditional public transport services to provide sustainable, better mobility that is equal and available to all. So, as you see, after much reasoning, this is how UITP has concluded that by employing AVs as shared vehicles, such as shuttle buses or in-car or ride-sharing schemes, AVs could drastically reduce car ownership, regain essential urban space, and result in better mobility for all. Now that we have determined the ideal manner in which AVs will fit into the urban transport ecosystem, let's talk about how we can make this happen. Without any doubt, public transport authorities, and particularly multimodal mobility authorities and public transport operators, will need to play an active and central role in the deployment and adoption of shared and autonomous mobility. We will need to test our driverless shuttles on our roads. Without partnerships, strong alliances, and working together, this shared vision of forming an integrated mobility universe will not succeed. We will also need to spend time and resources on getting our customers to feel comfortable riding AVs, but also to be prepared to have these vehicles around. These AVs must connect high-quality public transport networks that keep the consistency of the customer experience. This will also be achieved with integrated mobility platforms such as mobility as a service solutions. With these steps, we can surely set our sector up to the preferred choice of mobility. Having shared UITP's position on the future of urban transport, I'd like to tell you a bit about how we are contributing to making this a reality. The multitude of initiatives and projects we are involved in related to this topic is evidence enough that UITP is a strong supporter of this integrated world. Of course, I will not be able to cover it all, but I'd be happy to tell you a few more details about some key projects. Let's begin with SPACE, an abbreviation for Shared Personalized Automated Vehicles. This is a flagship project from UITP with the aim of placing public transport at the center of the automated vehicles revolution and helping to build the combined transport ecosystem. The SPACE project counts 57 partners from over 20 countries and was launched in March 2018. GECO is another project coordinated by UITP. GECO's main goal is to support authorities with tools and recommendations for new regulatory frameworks to lead the transition to the new mobility era of cooperative, inclusive, competitive, sustainable and interconnected mobility across all modes through evidence-based research. While there are many more initiatives I would like to speak about, in the interest of time, I'd like to put the spotlight on SHOW for a special reason. SHOW stands for Shared Automation Operating Models for Worldwide Adoption. This project is also being coordinated by UITP and aims to support the deployment of shared, connected and electrified automation in urban transport to advance sustainable urban mobility. During the project, real-life urban demonstrations taking place in 20 cities across Europe will see the integration of fleets of automated vehicles in public transport and demand-responsive transport, including mobility as a service and logistic as a service schemes. Does the objectives and description of SHOW sound familiar? In fact, it is quite similar to FABULOS and could be considered as a follow-up, if you will. The project aims to be the biggest and most holistic ever real-life CCAV urban demonstration initiative in Europe for shared mobility. With this project especially, we were able to set up excellent collaborations with FABULOS. There were extensive exchanges between both projects related to consultation activities, including a workshop on the topic that took place a couple of months ago. Here, FABULOS shared lessons learned and best practices with the show members, which will ensure that we waste no time in replicating work and, in fact, build upon their incredible learnings and achievements. This is valuable experience that will ensure the faster deployment and adoption of AVs, and we greatly appreciate this selfless sharing by the organizers of FABULOS. So, while we continue to work on this topic via various projects, I hope you will all join in our vision for the future, where we can arrange a convenient, seamless, and safe end-to-end experience for our riders that is sustainable, efficient, and accessible to all. I have no doubt that the results from FABULOS have accelerated the possibility of this vision coming to life in the near future. Again, congratulations to all involved, and thank you for inviting me to speak to you.